first thing we covered in this class was order of operations. And remember, I said that was very important to be successful in algebra. So remember, when we add two fractions, we do need to find common denominators. When we multiply numerator with numerator, denominator with denominator. And when we divide two fractions, we need to flip the second one, all right? The other topic is types of numbers. You know, most likely on the quiz, we're going to be asked to differentiate rational numbers from irrational numbers, right? Irrational numbers are those that you cannot express as a ratio, as a fraction, okay? So, and you should be able to give examples, okay? Like an example of irrational number is pi, okay? Pi is an irrational number. So do a little search, make a little table, and have that in your mind. And also be prepared to be able to explain what is the difference between those. Then the next topic, very important, is the idea of absolute value, right? Absolute value. So absolute value is basically the distance from a point in the number line and 0. So a distance is always positive, okay? Please remember that. So if I have absolute value is represented by a bar, 2 bars like that, okay? So that means, what is the absolute value of negative 5? 5, positive 5, right? It's a positive number, so it's the distance will always be positive. Now, also, if I have now a variable inside the brackets here, those bars, right? What would be the solution?
Either 5 or negative 5.
Either 5 or negative 5. There is always 2 solutions for absolute value. Because look, there are points to the right and points to the left of the 0, right? So the distance are the same. Distance from 2 and negative 2 to 0 is always 2 units, okay? Good. Then another one, very important, and the students always get a little confused, is order of operations. And on the last quiz, many students made the mistake about the division and multiplication, right? If I have, for instance, 2 divided by 4 and then multiplied by 3, it is different if I multiply this 2 first and then I divide. The answer is going to be different. And because of that, they had to establish a rule. The rule is always we start from left to right, okay? Left to right. That's the fine print on pandas, okay? All right. The next topic is percentage. Very important not to miss this one, okay? What is percentage? What is percentage? Means per cent means per 100, right? Per cent means per 100. So whatever we have, let's say I have $250. That's all I have, okay? So I just built a new scale. It's a new scale, okay? So 250, if I spend all, I'm gonna get what, 0, right? So I make a new scale from 250 to 0, right? But a scale of 100, okay? It's a measure, you know, of 100. So now 250 is equivalent to 100. It's a new scale. It's like, remember, we have inches, we have, you know, yards, we have feet. Those are different scales, right? We can measure my height in inches, and I can measure my height in feet, okay? So if I want to spend $50, I want to know what percentage of the total I have already spent. you know, so there should be a number here that is equivalent to 50, okay, in a proportion. If you build this table, you never miss any problem on percentage, okay? It's basically this distance here, all this 250 is equivalent to 100 divisions. 250 now is equivalent to 100 divisions. So you write 250 and 100 there, okay? And now I want to know what is 50, right? It's going to be proportional to x. And now here we can do cross multiplication and figure out the number on x, okay? Now, sometimes the problem is written a little different, okay? I give you 50, all right? And I say 50 is 20% of what number, okay? Now I'm saying that this 50 here is 20% of a maximum here, right? 100% here is going to be a certain number that I don't know. I want to figure out what it is, okay? So now I have here the total is the unknown, so I put the variable here, and I make the proportion x is going to be proportional to the 100, right? And here I have 20%, and here I have 50. Right? So in this case, I'm calculating the total. Is that okay? So next is the difference between expressions and equations. Anybody can tell me what is the difference between expression and equation? What do you think?
An equation has an equal sign.
An equation has an equal sign. That's one thing. That's very important. What else? If I ask you just what is an expression? If I say 26 years, what is that? Is that an expression or an equation? Huh? An expression, right? So what do you think 26 years is? It's just an idea, right? I could say beautiful, right? It's another idea, right? But if I say, I wish I am 26, right? This is a statement, right? So an equation is a statement. Okay? I am 26 years old, right? If I say just 26, could be 26 years of what? Of work, or could be 26 years of age, you know. All right? So if I write 2x, that's an idea, right? Alone is double, the double of x. That's an idea. If I write 26 alone, is also an idea. But if I put these two ideas together, right, connected with an equal sign, now I'm making a statement. I'm saying that 2x is 26. So what is the value of x? It's 13, right? And expressions can be evaluated. If I just write 2x, it could be anything because x is a variable. I could say x is 10. If x is 10, then the value of this expression is going to be 20. If I say the value of x is 5, then the value of this is going to be 10. Okay? So the next is how to solve an equation. Well, solving equations like 2x plus 3 equals 7, all right? Then you need to know properties of equality, right? You have to learn all those. Basically, properties of equality is whatever you do on the left side, you need to do on the right side. So in order to isolate the value of x, first you take 3 from this side and 3 from the other side, right? You have now 4, and now the next is divide by 2. Right? If you divide one side by 2, you need to divide the other side by 2. And then you got the answer. All right? So that's simple. Now, of course, it can be complicated if you start having fractions, right? If we have now x 2 plus 3 over 7 equals 2x, now, wow, you know, how I'm gonna solve this? Well, first thing, you have to find a common denominator here, right? Bring x to the other side, combine the like terms, and then find the value of x, okay? Now, inequalities. Inequalities is if I have 2x now greater than 26, 2x greater than 26 is not an equation anymore. This is an inequality, right? Remember, on the equation, we always find one value for x, one value. On an inequality, we're gonna find a range, okay? So, to find the values of x now here, I would have to divide by 2 on both sides, again, using properties of equality. And now, I'm saying that instead of x being equal to 13, I'm saying the x is greater than 13, okay? So now if we put the number line here, 0 and 13 is somewhere here, so how are we gonna represent that? All values here above 13 are valid solutions for this here. Because if I put 14 here, 14 is greater than 13, okay? So we set this way, goes to infinity, right? But 13 itself is not part of the solution. And for that, we're going to represent that with an open circle, okay? Well, sometimes we have, or another way to represent this is by using parentheses, 13, and then infinity, okay? So the interval between 13 and infinity. Another way to represent, again, is using set notation. So this here represents this set of numbers, x, so that x is greater than 13, okay? So it's important to know, you can answer this way, you can answer graphically, you can use interval notation, or you can use set notation. You know, on a final, for instance, they might ask, give me the set notation as the answer, okay? Or they can ask, give me the interval notation. So if you put this way, you're not going to get a full point for your problem, okay? So make sure you learn how to do all this, okay? So that's here, one inequality with one variable. Now, how we graph? Let's go to graphing now. Before we start with inequalities, with two variables. Let's talk about an equation with two variables, right? An equation with one variable, if I had 0 here, it would be easy to find the solution. You say, well, x is a certain value, right? That satisfies that. But here, with two variables, we have an infinite number of solutions. And the best way to represent that is by graphing, okay? Where here is the y-axis, this is the x-axis. If x is 0, y is going to be equal to 3. So x 0, y is equal to 3, so we have 1 point there. If x is 1, I'm going to have 5. And we see it jumped from 3 to 5, the value, just by moving from x0 to 1, okay? So this change here, for one change in x, is the rate of change in 1. And we call this here the slope, all right? And if we connect all the points on the line, we know it's going to be a straight line like that. So we can identify the slope we can identify the y-intercept. Also, very important is to identify the x-intercept. The x-intercept happens when we have here y equal to 0. When y is equal to 0, we find the value of the x-intercept. Okay? All right. So let's see. We got this one here covered. Now let's go back to inequalities. All right. If now instead of equal sign here, I have here written greater or equal. Okay, greater or equal. So if it's equal, the line is part of the solution. Okay, the line is part of the solution. The equation is a set of points that satisfy the equation. Okay, the line is a set of points that satisfy the equation. Now, this here is not an equation anymore; it's an inequality. So besides being equal, it is also greater than. So greater than the line. So that means any point here will satisfy. So if I pick this point here, right? What is this point? What is the order pair for this one? Is x0, y is 5, right? X is 0, y is 5. This point here, right, is above the line. If I plug in here, y is 5, x is 0, this is going to be 0, so it's going to be greater or equal than 3. And that's a true statement. So every point here is part of the solution. So we shade all that area to represent that any point here it is. Now, if I had, instead of greater or equal, just greater, so that means now that the line, the points here are not part of the solution. And for that, we're going to represent that with dotted line. Okay? So this is graphing one inequality. If we had a system of inequalities, then we would graph the other inequality the same way as this one. All right? Let's just imagine now that the line would look like this and would be less or equal, right? Y less or equal. So it would be a solid line, and less means below, right? So I would have to shade everything here. But the solution that would satisfy both inequalities would be here, the superposition of the shaded area. Okay? All right, so we covered this. We covered graphing. We covered linear equation slopes and intercepts. So let's just talk about exponents, and then we go to functions. Okay. Exponents. Exponent is 2 to 3 is an exponent. Okay, 3 is the exponent and 2 is the base. So there are a few properties that you guys need to remember about exponents, and it's going to be very important when we start working with polynomials, multiplication of the polynomials, so, and also division of polynomials. So knowing the properties of exponents is important. If I have am times an, I have to remember that's going to be the sum. If I have am divided by an, it's going to be subtraction here, subtract. It's going to be a negative, it's going to be 1 over an. A0 is always 1. It does, can be any number, and n or m can be any number. Okay? And I also have another one, m is going to be the product. Don't confuse this one with this one. Here is the product, and here is the sum. If I have a over b, m is going to be a m b m. Okay. If I have a times b, m is going to be a m b m. All right. So those are all properties that you need to know, and please do some problems so you become fluent with those. A typical problem on the quiz could be something like this: A, B, C -5 by A 4, B -4. So now here you need to be able to simplify this, okay? And for that you need to use those properties. Very important is never leave a final answer with a negative exponent, okay? And also give the simplest form. It's like a fraction, for instance. You're not going to leave an answer like this, 3/6. That's not the simplest form, okay, on a fraction. So this would be 1/2. So this has to be the final answer, not this one, okay? All right, so exponents is done. So now let's talk about function. Remember, when we graphed that, when we had 2x plus 3, one way to graph that is to build a table of x and y, all right? Different values of x and different values of y. Now, there is a relationship here between the values of x and the values of y. If I define a value of x here, y depends on that value. So that dependence, that's what we call, it is a function, all right? We say that y is a function of x. And one way to represent that is f of x, okay? Now, let's say now, if I have a function that is between only these 2 points, this is a function here, okay? A function that is between these 2 points. It is important to be able to identify what they call the domain. The domain are those values of x that this function exists, okay? So what would be the values that this function exists? Is the values of x within this interval, okay? So this here is the domain. This is the domain. And the range are the values of y that the function exists, okay? So those are, this is the range, okay? Well, why is this important? Well, let's say I have a function 1/x, okay? F of x is 1/x, 1/x. Does this function exist for any value of x?
No,
No. Why?
because it can't equal 0.
Exactly. X cannot be equal to 0. So there is one value, okay, that this does. So the domain would be, the domain would be set, the set of x, so that x is different than 0. So that is the domain, okay? So if you graph this function, how is this going to look like? If you graph this function, it's going to look something like this, okay? And something like this. So this is how this function looks like. So it never reaches, when x is 0, it never reaches any value there. So it doesn't exist, right? It goes to infinity there, so you can't represent the function at that point. Now, what would be the range? This is the domain. What would be the range? What are the values of y that this function exists? Huh? It's the same, right? Also, y, you never get a value of 0 for y, right? This function here will never assume the value of 0. So the range would be the set of y's so that y is different than 0. So that would be the range. Okay? Now, if I have 1 over x plus 2, what is the domain here now? Can x be 0?
Yes.
So what is the value of x that this function cannot?
Minus 2.
Minus 2. So if I put minus 2 here, minus 2 with 2 is going to be 0. So that's it. So the domain now here is going to be set of x so that x is different than minus 2. Okay? That would be the domain for this one. All right? So we cover domain and range. Now, let's talk about the piecewise function. Piecewise function. So let's say I have f of x when f of x is 1 when x is greater than 0, and 2x when x is less or equal than 0. Okay? So, so this is what is called piecewise function or step, right? There is a step here. If I graph this, when x is greater than 0, so x is here, right? This is 0. Greater than 0, the value of the function is always 1. It doesn't change. It's always 1. So it goes like this, straight. Okay? Here's an open circle because at that point it's not clear where it is. Now here I'm saying the function for x less than 0 on this side, the function is going to behave as a 2x. Okay? So when x is 0, what is the value of the function? Well, it's going to be 0. So I have one solid point here. Okay? When x is negative 1, right? Negative 1, the value of the function is going to be negative 2. So negative 1, negative 2. So that's another point here. So straight line here. So you see that the function behaves differently in different intervals. From this interval, x less or equal than 0, it behaves as a straight line with the slope 2. The y-intercept is 0. But when x is greater than 0, it behaves as a constant function. Okay? So that's the idea of the piecewise or step function. So on a problem, could be that the test might give you the graph of a function, and you need to write the equation, or they give you the equation and you need to draw the graph. Okay? The other one is the absolute value function. So if I have f of x equals absolute value of x, how is this going to look like? If you do the table with negatives and positive numbers, right? Do the table for negative and positive numbers, you're going to see that there is a v. This is the typical look of an absolute value function. Now, the function could be different. Could be 2x plus 3 minus 4, for instance. So what is that going to mean? Well, here, this now has a slope is different than this case here. The slope here is 1, so this is a 45-degree line. If the slope is 2, this line is going to be a little closer to the y-axis. So it's going to be like that. Then I have here plus 3, so that's going to represent a shift on the x-axis, either to the right or to the left. And then I have a negative 4, that means a shift down on the y-axis. So here, the shift is in the y-axis. This here represents a shift in the x-axis. All right? Exponential function. Well, exponential function, what does that mean? A function that depends on x, but is exponential. So the variable is an exponent. Okay? This is an example of an exponential function. Okay? How this going to look like? An exponential function usually is going to look like this. When x is 0, what is the value of the function?
1.
1. Very good. That's it. 1 here. When x is a very high number, what's going to be the value of the function? A very high number, right? It's going something like this. When x is a negative number, what's going to happen? Is this line going up or is going down? If the x is a negative number? Down. And the greater the value, absolute value of x, the smaller is going to be the function. It's never going to touch 0. This function will never be 0. Okay? But that's how an exponential function looks like. Now, if I put a negative here, what's going to happen with the graph? This is the graph of positive, right? Positive x. If I put a negative here, how is that going to look like?
Sure, it's going to be rational number.
How's the graph going to look like? It's going to flip down. It's going to flip to the side. What do you think? So please try to do at home, okay? Try to graph them. Find this one and then the negative one. The answer is going to be like this, okay? It's just a reflection. Because now, the positive values of x are going to be really small numbers, right? Okay? Okay, so we finish with functions.
You mean when it's the top like minus, it's going to be down the graph?
Yeah, if I have like a f of x,
When x...
negative, when it's negative x, right? It's going to look like this. Still going through 1, but now negative with negative is a positive number, right? And when the absolute value of the negative is very high, so you're going to have a high number here. Now here, a positive number, if I enter a positive number here, this is going to be negative. So it's going to be smaller and smaller to the other side. All right? So let's move to our last topic, and that is the idea of polynomials. We start with 2x. 2x alone is a monomial. It has only one term. Mono means one. Poly means what? Many, right? So if I do this, this is called what? Has two terms. If it has one term, it's called monomial, right? If I have two terms, it's called?
Polynomial.
Huh?
Polynomial.
Yeah, but this is a special polynomial. It has only two terms.
Binomial.
Binomial. Bi means two, right? If I have three terms, like here, this has three terms, is that it's going to be called? Trinomial. Trinomial, okay. All right. So one thing is we can add, this is a monomial, This is another monomial. I can add these two guys. If I add them, I get a binomial, okay? I have 2x plus 3, now I have a binomial. I can also multiply. 2x times 3 is going to be 6x, okay? So multiplying monomials is easy. Now let's say I want to multiply a binomial. So I'm going to have to apply the distributive property, right? This is going to be 4x plus 6, okay? Now this is easy because this here is a number. Let's say now I want to multiply the binomial by x. I want to multiply this binomial now by x. What's going to be? If I distribute this, what's going to look like?
2x squared plus 3x.
2x squared plus 3x, okay? All right? Now, if I want to add these two, if I want to add this guy with this guy, right? If I want to add this guy and this guy, I'm going to have this plus this, right? I'm going to have 2x squared plus 3x plus 4x plus 6. Oh, this is like terms. I can combine them. 2x plus 7x plus 6, okay? So what we did here is distributive, right? We also distributed this here. Now if I want to multiply if I multiply x plus 2, right? X plus 2 times 2x plus 3, how we solve that? Well, the same way, we distribute. It's called the FOIL method. First we multiply this guy times this guy. It will be 2x squared. This guy times 3x. 2 times will be 4x. And then 2 times 6. And that is exactly what we have here, okay? So this is multiplication of polynomials.
Can we say for this one to like x plus 6 multiply x plus 1? No, for this one.
For this one?
No, 2x squared plus 7 plus 6.
Yes. Yeah,
It's
that's
okay, like we can open x plus 6 multiply x plus 1
x
plus 6 multiply.
x plus 1, like that?
Yes, I mean it's the same open when we
You
open
think,
the.
you think this is gonna be the same as that?
Well, because there's 2x squared. So.
Yeah, there is a 2x there.
Yes,
It doesn't work,
doesn't work.
no?
Yes.
It's okay to guess things, but then you need to test, right? Well, if I multiply x times x, I'm gonna have x squared. X times 1 is gonna be x, 6x, and then 6. So this is gonna be x squared plus 7x plus 6. This is not the same as that, so it doesn't work. Okay, but that's, you're trying to factor, right?
Yes.
We didn't cover that yet. That's the next step, okay? Let's focus now just on multiplication. I'm just trying to cover the technique how to multiply binomials, okay? And the utilization of the FOIL method. All right? Okay. So now let's talk about, we did addition, right? Addition of polynomials. Let's talk about subtraction because it's very tricky. If I say subtract 2x squared minus x from 3x squared minus 3x plus 7, how do you set up that problem? Well, subtract what? This expression from this one, okay? So, it's like subtracting 3 from 5. how would you set that up? You would write 5 minus 3, right? So you're gonna write this 3x squared minus 3x plus 7, and minus, because I'm asking you to subtract this quantity here, and you have to put that in parentheses, okay? Remember, you have to put this, this is an expression. This represents a quantity, this represents one number. You cannot do that without putting the parentheses. Now, you're gonna have to distribute this negative here, and you're gonna change the signs there. So you're gonna have 3x squared minus 3x plus 7 minus 2x squared plus x, because now this one changed the sign. Now you combine the like terms, okay? And that would be your final answer. All right? And the last topic is division. How to divide, if I have, for instance, 4x cubed plus 3x squared minus 7 divided by 2x, how are you going to do that division? Well, this here is a polynomial, and here we have a monomial. When we divide by a monomial, we're going to divide each term by the monomial, okay? It's this divided by this divided by this, and that divided by that. So here, 4 divided by 2 is 2. X cubed divided by x is going to be x squared. Now, this one plus 3 divided by 2 is going to be 3 divided by 2, and then x. And the last one is going to be negative 7 over 2x, okay? I cannot divide that, I just leave it like this. So, it is easy to divide by a monomial, okay? Now, how are we going to divide by a binomial? Well, now you need to work with the long division. Let's say I have 2x that you want to divide, let's say x cubed plus, let's say put 2 here, and then 3x squared minus x plus 5. How do you do this long division? You have to look at this term here and x. What is the term that multiplied x is going to give me 2x cubed? 2x squared. So I put 2x squared, multiply this, I'm going to get 2x cubed. But remember, now I'm multiplying the binomial, so I need to multiply both sides. It's going to be 2x cubed. Now 2 times this is going to be negative 4x squared. Remember, this is an expression. You need to put parentheses, and you need to subtract that. Now, it's going to change the sign. I'm going to cancel that. This is going to be positive. I'm going to add, and then x. Now, the next step. What is the value here? What is the term here that times x is going to give you 2x squared? It's going to be what? 7x. 7x times x is going to be 7x squared. 7x times 2 is going to be negative 14x. Parentheses again, negative. This is going to be negative. It's going to cancel. It's going to be positive. So this is going to be positive 13x. And then I bring down the next one. That is 5. And then here is going to be what? 13. So 13x. Now, negative 2 is going to be negative 26. Again, negative. This is going to cancel. This is going to be positive. And then I'm going to have 31. 31 is my remainder. And the total answer is going to be 31 over x minus 2. So this would be my answer. It's like, for instance, if I have 371 and 2. Okay? How do I divide that? How many times 2 goes into 3? 1, right? 1 times 2, 2 here, and then I subtract, remember, subtract, right? And then I have 1, brings 7 down, 17. How many times 2 goes into 17? 8. Now I have 16, subtract, and then 1, bring another 1 down. Now 5, and then I have here 10, and 1 is the remainder, so 371 divided by 2 is 185 plus 1 over 2. Okay? All right? 185 plus 1 over 2. Okay. So, we covered that. Now let's talk about synthetic division. Okay? If I ask you to divide it, this is the long division. If I ask you to divide by synthetic division, you're going to have to, the strategy is to build here. You pick up this number here, this negative 2. Because we have negative here, you have to multiply this here by always by negative. Negative 2 times negative 1 is going to be positive 2. So you put positive 2 here. Then you have the coefficients. 2, 3, negative 1, and 5. So the strategy here is this. You bring this guy down, okay? You multiply 2 times 2 is 4. You put 4 here, okay? And you bring it here. Now, this is going to be 7. 2 times 7 is 14. Bring 14 here. Then it's going to be 13. 2 times this is going to be 26. Bring 26 here. And you add that, that's 31. All right? So, the strategy is this. You pick up this term, the last term, multiply times negative 1. So negative 2 times negative 1 is 2. You put that here, okay? This goes here, okay? Now, what are those values? Those are the coefficients of the polynomial that I want to divide. 2, 3, this one is negative 1, and then 5, okay? Then, you bring the first one down, put it here, you multiply. 2 times 2 is 4. Plug in here. Add 3 plus 4, 7. Okay? Multiply 2 times 7, 14. Plug in here. Add 13. 2 times 13, 26. Plug in here and you add, and that's the remainder, right? Now, division of polynomials is reducing the degree. So if the polynomial has degree 3, if I divide it by 1, it's going to be degree 2. So how do I find the value here of x? It's going to be 2. This is going to be 7, 1, right? And then 13, and then 31 divided by x minus 2. Okay? All right? Okay. That's the review.